Welcome. This is lecture 10. We look at the chain rule, and we have just got news that the Mars rover, the new Mars rover Perseverance, has landed successfully. Hopefully everything is going well. And I just made up a problem here which could appear in such a mission, so that we have a height function. You know, we have the height changing in time. So the x is time, this is the height, and this is maybe pressure or something we measure depending on the height. And then what we are interested in, the rate of change of the pressure. So what we are interested in is the rate of change of this function e to the minus x. So how do we compute the derivative of this? So that gives us the rate of change of the pressure depending on time. And the answer is given by the chain rule. The chain rule tells us that if we take the derivative of maybe I take f of g of x, that is equal to f prime g of x times g prime of x. So that's the chain rule. And in this example, typical example here, we get so this is equal to, and then minus sinus of e to the minus 6 times e to the minus 6 with a minus sign here. And so just move this away. And that minus cancels, so e to the minus 6 times e to the minus 6. So that's the rate of change of the pressure in time. This is positive rate of change. Very quickly, why does this chain rule work? So what we can do is we can just go back to the definition of the derivative. So what we have is we have to look at f of g x plus h minus f of g of x, and then divide by h, and then take the limit when h goes to 0. That's the derivative of limit when h goes to 0. That's the derivative of f of g of x. So let's just see what we actually get here. So we can now modify this and kind of just multiply and divide by the same thing. What I can do is I can multiply by gx plus h minus gx, and I divide it by gx plus h minus gx. So why did we do that? Because this part here goes to g prime x. And this part here we can write a little bit differently. So what we can write, this part here, we can write as f g of x plus h minus f of g of x over h. And that h is that part which we actually have kind of defined here. So that is the h here, and that's the h. You see that? When I have gx plus h, then the gx goes away and the gx plus h is here. So gx plus capital H is what we have here. The f of g of x didn't change. But when h and capital H goes to 0, of course when small h goes to 0, then this goes to 0. So then also that goes. So this is when small h goes to 0, then so when small h goes to 0, then capital H goes to 0, and that goes to f prime g of x. So what we see is that actually this is equal to f prime g of x times g prime of x. quite easily done. There is a connection with the Lord of the Rings saga. So this rule, this chain rule, is quite universal. It actually implies so the chain rule allows you to derive the product rule, and it allows you to derive the reciprocal rule or the quotient rule. So I will explain this in class when I do the slides. So it's kind of one ring, right? So this is one ring. So this is the ring which binds them all. But there is another connection, and that comes with a creature, Smeagol or Gollum. And you take the derivative, like if you take the derivative of e to the sine x. What happens is you treat this is Smeagol, and for a moment you treat it as Gollum. So this is actually, let's call it G for Gollum, right? So this is f of g. So d over dx, f of g of x. That's f prime g of x times g prime x. So for a moment this thing becomes another entity, it becomes a variable, and then you differentiate with respect to this variable, and so what we get is we get e to the g, e to the sinus x. And then we take the derivative of and Gollum becomes again Smeagol. So it becomes cosine x. So it's Smeagol again. So we start with Smeagol, then becomes Gollum, differentiate, becomes Smeagol again. So that's one of the things. It's a schizophrenic rule. And that makes it difficult also to write about the chain rule, because at some point here you treat this function as a variable. Okay, in this last part 4, I want to tell you how you differentiate inverse functions. Like, how do you differentiate arcsin? The chain rule will help. So what we can do is we can just say sine of arc sine of x is equal to x, because it's the inverse function. Now we differentiate this. Take the derivative, d over dx. Of course that's equal to 1. If you take the derivative of x, you get 1. And here we know now by the chain rule, we can apply the chain rule. And we get cosine of arc sine of x times arc sine prime of x. That's what we don't know. That's equal to 1. So that's what we are interested in. And we can solve for this. So we see arc sine derivative is actually 1 over cosine arc sine of x. So that's already an answer. We could leave it like this, but it's actually convenient to write this down a little bit differently. You all know that sine square x plus cosine square x is equal to 1. So cosine x is the square root of 1 minus sine square x. That's what we can do here. So we have 1 over the square root of 1 minus sine square of arc sine of x. Now the sine of arc sine of x is equal to x. The sine square arc sine of x is x times x. So that's equal to this 1 over the square root of 1 minus x squared. And that's very useful to know. This formula here is quite useful to know. Arc sine of x is equal to 1 over square root of 1 minus x squared. And we practice this with other functions, and you practice this in the homework, it's a very nice application of the chain rule.